Okay, this is live. What is this, Lady Ada?
Hi, everybody, and welcome to our weekly show and tell. It's what we do every week at 7:30 p.m. Eastern Time. It's me, Lady Ada. With me, I've got special guest, Bill from AT Makers, and, of course, Phil on camera control. So we have Phil and Bill. Do not confuse them. One is wearing green, one's wearing black. That's how you can tell the difference. But we're not going to talk about Bill and Phil. We're going to talk about you, the makers, the creators, the hackers, and the people who are going to show off their awesome things for the next half an hour. We're so excited. This is your time to show and tell your projects. We're going to start off with some Adafruit peeps, then call on other people, get out of here at 7:50. So take 2 to 3 minutes when we call on you to demo your project.
All right,
love to see it.
Noe Pedro.
Hey everybody, this week we have a interesting project with .Star LEDs. These are those high-speed PWM LEDs, and Lamar, you wrote some Python code to make a POV, persistence of vision display. So what I did was I 3D printed a stick and added the strips to the stick.
Is that me and Phil?
Yeah, that is you guys. Yeah. So what's cool is when you use a long exposure, you can really showcase it here.
It's like one of Caitlin's dad's projects. It's like,
it's so meta. It's you guys looking at yourselves as 8-bit. But it's 32 LEDs tall. You can go about 72 pixels wide. It supports bitmaps and anything else that you guys want to know about it. Check out the guide on the learning system. It's, I think it's one of the easier POV projects. We have a ton of really great POV builds on the learning system. This one's really kind of easy to put together. Not too many parts. Especially since it's on the Feather M0. Yeah, you got to turn down the exposure. The exposure.
Yeah, I can't do that right now.
Yeah, I practiced before. Yeah. That's a lot of fun. So it's
thank you.
Python, so you can quickly change the code and change the bitmaps around. So it's a lot of fun.
All right, thank you so much, Pedro. That's super cool.
Yeah, thanks guys.
All right,
next up, JP.
We're gonna go to JP because Scott's doing his demo. Okay, JP, how's it going?
Hey, great guys. So I actually don't have something to show that I've built, but I have got something to show that I'm going to build. So this is a tease for my live stream tomorrow at 4 o'clock Eastern time. I'm going to be putting together something that starts with this, and there's probably some of you who will find that familiar. That's the CX40 PCB, which is the Atari 2600 joystick. And I remember taking these apart and cleaning them and getting them working again when I was a kid. These are going to be the little, I'm going to pull off these little wires here, and we're going to have these nice contacts, which are 5 switches and a ground. And what I'm going to be connecting those to, here's my joystick, and something that happens to fit really nicely inside of there is the NRF52 Feather. So that's a Bluetooth, going to be a Bluetooth keyboard acting as a controller. So I'm going to be putting that together tomorrow, and I'm going to do my best to non-destructively build that in here, including a little charger and a switch. So it should be a pretty interesting project. I think we'll succeed. I got code running on it, but I haven't tried it all together, so it'll be a bit of a real-time experiment tomorrow at 4.
Okay.
All right, JP, cannot wait.
All right, next up.
Scott.
Scott.
You ready?
Ready for live demos.
It doesn't work.
It's never too late to quit something that's not working.
So I'll just talk about what I'm doing, because really what I want is I want to find somebody who can help me with this.
I'll send you a Sparky pen.
I think I got one, because we gave them away at Open Hardware Summit. I got one from there. Anyway, so what I'm working on is I got really distracted today getting a super simple serial app going. Which the idea being you just turn it on, you just double click the app, and then you get connections to all your Adafruit boards, serial connections. I'm using Electron. So if you know how to do Electron, please let me know. I'm basing it off an existing terminal that's done in Electron, because they have like all of the tool chain working and everything. So I'm pretty close. I had it actually connecting to a CircuitPython board earlier. What I was trying to get done right now that doesn't work is the title bar. So if there's multiple boards that you have plugged in, like I have 2 boards here, you get 2 tabs, 1 for each board, and then you'd be able to connect to the serial super duper easily. So if somebody is interested in this project, contact me on Discord or email me, Scott@adafruit.com, and I'll help you get on Discord.
Okay.
If you work
that
on
would be super helpful.
if you work on this and impress Scott, we have budget, and some people end up just like working at Adafruit. Like that's the job application. Yay.
Yep.
Putting jobs in the economy.
All right.
With open source. All right. Well, thanks, Scott.
Yeah. So I hope to hear from people.
Okay. All right. Next, Dave. How's it going, Dave? I think I know what you're working on.
All right, you're back.
Hey, Dave.
Hey.
Hey.
How you doing?
Hey. So I got a couple things. My headset wasn't working last time, so we did the charades. I actually have the circuit up and running on a circuit board now.
That's cool.
And the idea here, this is sort of extracted from some of my smart home nodes, like under counter lighting. You walk up to the counter to do something, the lights come on, you walk away, they turn off. So that's the whole idea here. We have the VL53, was it? Yeah, VL53 LOX. So as you walk up to it, the NeoPixels turn on, you back away, they turn off. I think it's set for about 0.5 meter now. So I'm just using a simple, here I'll do this so it doesn't blind everyone, little 8 NeoPixel strip that I've been using for ages for various projects, but they're nice and bright. So this would be good for like on a bookcase or a piece of artwork. That's kind of focused spotlight. So that's one thing. That project's pretty much done now. The other thing I've been playing with is this, which you guys have one too, I believe.
Twins. Look at
Yeah.
this. Yeah.
Twinsies.
So I've been playing with this. It's really neat. This is a sino bit. Naomi is, I guess, responsible for this, and then Electron built it, designed it and built it. It's like a, for anyone that doesn't know, it's like a microbit or a calliope, except with lots of LEDs, 12 by 12 LED matrix, which lets you do some fun things like Conway's Game of Life.
Oh, that's cool. This is also the first open source hardware certified open source hardware in China. So when they, it's very easy. You just send your files, and they just need to be open source, and they'll assign you a number. We're in the USA, so a few of our boards, I think it started at like 152. It's 00001. CN0001. That's cool.
Yep.
Yeah, right there on the back.
Okay.
So yeah, it's a really cool board. One of the neat things is you have all these LEDs, but because there's so many LEDs, it's using this Holtec, the HT1632 that you guys use for some of your LED matrix controllers. That offloads all of the processing for controlling and multiplexing the LED array from the MCU. So it lets the MCU run at full speed without having to take cycles to do the LEDs, which is pretty impressive. That life program running, their power LED is way too bright, by the way. That has a 200 millisecond delay just to sleep in between each generation. And if you take that delay out, it just blurs.
That's cool.
It's really nice and fast. And the connector, just the 2 by 13 connector is going to be amazing for doing like expansion boards and whatnot.
Yeah.
So that's what's been keeping me busy. I'm working on a learning guide for it, which is sort of a derivative of the microbit guide, because it's the same MCU, so most of the stuff is the same. Like the mag and Excel, that's all the same as in the microbit. So that should be ready within a few days, hopefully.
Okay. Thanks
cool.
Thanks so much, Dave. And then also, Naomi's in the chat room in YouTube if anyone wants to say hi.
Cool. Hey.
Hey.
I've been talking to her and the Electron guys.
Yeah, this is cool. I just like it. Being the first of something is not the most important thing, but boy, it's fun. It's like the first open source hardware in China. It's a big deal. All right. Thanks, Dave.
Yeah. Okay.
All right. I want to make sure. I want to say Seon, but it might Sean. Yeah, it might be a couple different pronunciations.
Hi, everyone. No, Seon was correct.
Oh, Seon. All right.
Okay.
Yeah, well done, well done. I'll try to keep this short. So I've been building a digital version of this, which is an analog ADHD timer for kids that have got ADHD.
Oh, there you go.
Yeah.
And so this has been a really long journey. I'll quickly show you what I've got right now. This is my revision A. So it's, as you can see, it's quite bulky. I'll turn it on. You can't really see. I'm going to use that paper trick. You might not be able to see very well.
Oh, yeah. Ready.
kind of see it's on there, and you can set time on it, and then you can trigger it off. And when it's finished, it does the beeping stuff. So I'm building this for my daughter, and it started off as on a breadboard, and then it turned into this really ugly prototype board, as you can see here. And I have a feather that plugs in over there, and the TFT plugs in on the back. And so then my next revision, I designed my first PCB.
Oh, nice.
That's the same thing, but no ugly wires, which is what my current unit's working from. What I'm going to do is pull this apart and show you. So as you can see inside here, there's you might not be able to see, there's a screen, and then there's the board with the feather sitting on the back. Whoops. And so I thought, okay, so next step would be to design another PCB, and I've made my first microcontroller board, as you can see here, thanks to the wonderful info on your feathers and having it all open source and dissecting it in Eagle. And so I've put together my first PCB. Wow. Unfortunately, I ordered the wrong Schottky diodes and the wrong size crystal, but they're being delivered today, so I'll be able to finish this board. And of course, forgot to put a header on it to program the SAMD21. But I did put the pins on the back, so I'm going to just hand solder those for the moment. Okay. And use Admiral Ice to program my chip. So I have no idea if this board's going to work. It probably won't. It'll probably blow up in my face. But that's okay. It's a learning process. So I hope that next week I'll be able to come back and show you the finished product, and hopefully get this package down to 1/4 of the size, because it's just too bulky.
Cool.
But it's been a wonderful journey, and I've learned so much, and it's all been because of the wonderful open source nature of Adafruit. It's just basically anything I want to learn, I can, because you guys share everything. So it's been fantastic.
Well, thanks. And your adventure's not over, because you get an As Seen on the Show and Tell sticker.
Thank you.
So there's plenty of room on that enclosure for it. Email support at Adafruit.com, and we'll send you one. And then as you wrap up your project, email PT at Adafruit if you want to ever document or something. We can set you up on a LearnGuide account and more.
Awesome. Thank you.
Or you can also just send us a photo, and we'll blog it up. Okay. Cool. Next, GB. Hello, GB. How are you?
GB is made
I'm good. Can you hear me?
Yeah.
All right, nice. So this right here is a 4-bit ALU. It's a work in progress. So I've been obsessed with microcontrollers for a while and small computers. Been familiar with like the hardware, like the outside. I actually have a bunch of CPUs sitting on my desk right now next to me. And I've always been familiar with the outside, like graphics cards, power supplies, but I always wanted to know what makes them tick, what actually does what's doing all the things. So I started working on this. I actually started building this earlier today, so this is all the progress I have in one day for it, but I can kind of explain how it is. So here are the commands. So might be kind of boring, but if you don't know how to read binary, this is going to be kind of difficult for you. But I can explain how it works. So just like here's your inputs. You have 4 inputs because it's 4-bit. You can go up to 15. Then you have your numerical or command selector. Then you have your enable selector, which pretty much just shoves everything from here through here and does a bunch of cool stuff. So what do you want it to add or subtract?
I want to add 2 plus 4.
All right, let's do that. So let's add 2. First, you have to make sure it's in numerical.
You just did this today, by the way?
Yeah, I built this today.
Good work.
So, yeah, thanks. So first, you put 2 into the first register, first input. Then you want to load that to register A. So first, you put that into command mode, put it to 1, which you see register A is pretty much 1 in binary. So you set that to 1. So all right, you have. So if you look right here, you'll see you actually have 2 right here. So now you want to put 4 in, which is this. I'm pretty sure it's that. So now you're going to set that to first register. Set that to section 2, register 2, command mode. Put it here. And now we're going to just make sure that everything's good. Yep, you see your data's right there. Actually add it. The adding command is the first 2 bits plus command. And if I scroll way out, my computer's probably going to die because it can barely handle this. And then this is your adding output. It's going to go into more things once this is done.
You can do it.
I'll flip the enable switch, and 6.
Yay!
All right.
Nice.
In the name of that app, some folks that is Logically.
Yeah, logically.
This is cool. This looks like an org chart for an electronics company, and it's electronics. This is very cool.
Well, you can add very small numbers together.
Yeah.
Yep.
This is super cool.
It's amazing.
Yeah.
Good work. All right. Well, you can get a sticker that can go on your computer after it melts down from all this processing. But email support@Adafruit.com, and we'll send you out one.
Nice.
All right. Thank you, Julie. Yeah, I can't wait to see what you do tomorrow. I mean, you got a lot done today.
It's and beyond.
Yeah.
Make a risk processor.
All right. So we still got about
Simulation.
10 minutes. If everyone could just make sure they go pretty fast, we can get to everybody. All right. Next up, Coding Pro.
Coding Pro, what are you up to this week?
Okay, so I've been working around with some LEDs for maybe a while, and since it's getting a bit close to the holidays, I was playing with them to make some things light up, like I have these an LED inside this hot glue thing.
Oh, nice.
And since a normal LED would just, if it's not, doesn't have like the flattened top, it just shines perfectly straight. Mm-hmm. So if you can add some more, like, it will spread the light out if you have more of a shape to it, and it's pretty easy to shape hot glue with wax. I mean, not wax paper, parchment paper. You can just put the hot glue on it, and the little pieces just come off really easily. Cool. And since it's show and tell, I made a special show and tell.
Yay, it's red. Sweet.
Cool.
All right, fun. Hot glue is fun to, like, it's really cheap, so it's kind of fun to mess with, to make shapes. It's like molding, but you can mold it with your hands a little bit through the paper. All right, good work.
All right, well, there's sort of room near it for a show and tell sticker. So email support@adafruit.com and we will send you out one. Thank you so much, Coding Pro. Excellent project.
Cool. Thank you.
You've been stopping by. It's cool to watch all of them.
Bye.
Kitchen Tronics.
All right, we're going to go to Adam, and then we will wrap up with CScott. Adam, what are you looking at under a microscope this week?
Nothing today.
What?
Yeah, it's not working right
now. Are you getting into telescopes? Are you going to look at the secrets of the universe now?
I wish, but not today. This is my Electron gun right here. And the fact that it's outside the SEM should tell you something. If you look at this, it's very, very blue and somewhat brown, which is a really, really bad sign. It means that there's some atmosphere in the Electron gun that caused the tungsten filament to burn out prematurely. It's like a light bulb. You can't have any atmosphere around it. That's one of the reasons you need to vacuum.
You've got the blues, is what you're saying.
Yeah, and that filament's like $100, and I don't have very many more of them, so I have to be very, very careful not to burn any more out. So I borrowed this amazing piece of kit. This is called an RGA, or a Residual Gas Analyzer, and it's basically a small mass spectrometer, and it can detect what type of gas is inside of the scan column at vacuum. So it can look just at basically individual atoms and count them. And what we can do with that is hook them up to hook this up to the controller and my oscilloscope. And there's a test port on the back of the stem there. So set that thing in there. And then I can start spraying helium around all of the vacuum joints on the stem. And if there's a leak somewhere, the helium will get in at certain points. And then the residual gas analyzer, the RGA, will detect a spike in helium. And there's a speaker that will start buzzing at me and tell me I found the leak.
Oh, that's smart.
So I can run through that, make sure I get all the atmosphere out, and that will be great. And I've just got a few photos to show of some of the related processes real quick.
You literally have blue smoke that comes out of something when it's not working now. So thanks for fulfilling prophecy of Sparky.
This is the first thing I've truly smoked in this thing. So yeah, you can look kind of at the filaments. You can see there's a little hairpin, just a little bit of burnt out right there. And it's blue is okay if it's just blue and it's really light. But this is really heavy, and there's a little bit of brown in the center. And we can go to some other photos of the inside. And we got the blue and brown stripes, like this rainbow pattern is bad rainbow. Usually rainbows are great. This one's not. And there's one more, and you can just see. So it definitely sputtered itself all over. It's not pretty. It's gonna be fun to clean it all out. But it is a cool piece of kit I get to use. This is what the inside of the Electron gun chamber looks like.
that gun I just held mounts up to this piece right here. This is the 40 kV feed or ceramic insulator, and then down here is the base of the chamber. This is significantly nicer condition than my ISI was. As you can see, it's really nice and shiny and polished. I don't have to go through and spend hours and hours and hours polishing it like I did the other one. As far as for what else is going on this week, my shop's freezing. Literally. It got too cold to run the SEM because this is my garage door, and that's the outside. This isn't a matter of do I need insulation. I need to reduce the amount of cubic feet per minute of airflow through the shop right now to even come close to being able to heat it. So I tried doing a cold start on the microscope, and about half the power supplies just decided they did not like anything and didn't turn on properly, and the safety system's like, nope, we're not doing this today.
Yeah.
So yay for cold electronics. Normally it's fine. In this case, no. So.
All right. Well, you have some fun problems to solve and some blue smoke to keep from escape.
Yeah, it's going to be interesting. So.
All right.
Oh, and one other thing, I got lucky with this RGA. This was from the place I got the. I'm borrowing this from the place I got the microscope. They had never used this thing while the current owner was there, but we actually found the adapter for this RGA to the service port on this microscope. So it's been used for this before, just not in years. So we'll see if it still works.
Okay. Good luck.
All right. Well, thank you so much, Adam. We'll see you maybe next week. And whatever type of blue smoke entity you want, we'll send out to you, of course.
Okay.
You name it, we'll do it. Okay. CScott, play us out.
Hey, guys. Hear me okay?
Yeah.
Okay. I have a bit of a cold, but anyway, I've been working on Old Crow's module playground. The device you see sitting here is a 10U module that on the back has the Feather M0 Express. Get it in the camera here. But this is my first foray, and I've just disturbed my cabling, into CircuitPython. You know what it looks like. Here, no, I look like too. Anyway, pop it. Over here.
Okay.
There we go. Sorry about that.
All right. That's great.
But okay, more interesting than me is I've just been adapting my my microcontroller code that I use in 328 directly to CircuitPython, and it's pretty much gone flawlessly. I was concerned with, will the machine be fast enough to interpret the MIDI and play the gates and CVs and stuff, and it is. It's plenty fast enough. In fact, it may be fast enough for my next step, which is to try and have it play samples out of the DAC port on the Feather to be able to sound some tones without having to attach to external
We can send you an M4, by the way.
We have an M4.
Pardon?
We have an M4 version that's even faster.
It's 120 megahertz, and it's the Cortex M4.
But keep working on it how you are. I mean,
that'll simplify things a bit.
Yeah. Drop me a note. We'll send you one.
We'll hook you up.
Do me a favor, please bring M clock out to a pin so I can use a 4-wire I2S stack. Anyway.
Lady A's got you covered.
No, because I was like, oh my god, if I mess that up, CScott's gonna kill me.
Yeah.
But
you're a feature.
I'll keep you updated on that module as I get it further along. I would have it doing like CV control of an oscillator, but I don't have a step-up amplifier on the board. It's 0 to 3.3 volts, and oscillators like to pitch control from 0 to 5 volts, but I'll fix it. Anyway, story number 2 involves running into a problem at work where we have one of those Bluetooth sound bars you put under your television.
Yeah.
And in order for an exhibit to work, you have to be able to switch everything on from a single power source, and it all just starts. You can't go around hitting stuff with remotes and manually starting things up, because you're not going to have an on-site expert all the time. You're going to have some guy that's representing the company the exhibit's for, and all they want to do is press a switch and go have coffee or whatever. Anyway, the problem with the soundbar is when it turns on, it's default to a dormant standby mode. And I'm going, well, we can send an IR code out from the Pi to start it. So I used the stuff on the Pi that lets you record a code and send it out, and it wasn't working right. I mean, it was rendering the codes and stuff, I was like, well, what's wrong? It should be working. I wish I had something else I could record and send information with. I'm like, oh, wait a minute. This'll do that.
Ding dong.
So I used the IR record and playback function to record the same remote, and it worked fine. It controlled the sound bar without a hitch. So it turns out that for some reason, the IR record app in the Pi's suite of tools is giving me the wrong mark and space interval numbers. And your guy's not doing it. It's giving me the correct one. So once I adjusted those, everything worked great. So, you know, CircuitPython and Playground Express to the rescue.
Yay.
Yeah.
All right. Well, thank you so much, Scott. That's a nice tip. If you want to blog that or something, because I've been in that world before too, where it's like, okay, you have to drop off the kiosk, and like that's the last time you'll ever see kiosk, unless it's 2 in the morning because it's a different time zone, and someone's like, we can't turn it
Ringing.
on.
Hey, I don't.
Yeah. So that's pretty smart.
Yeah.
Okay.
Okay.
All right. Well, yeah. Thank you, everybody. Thank you, Adam. Thank you, Codingpro.
My Brian Anderson.
Oh, look at this. He has a scene on the show.
Oh man, they really did all the
Wow.
icons.
Oh, it's like a hologram sticker. Showed up. All right, we're here. Thank you, everybody, for making it the best half an hour of our lives. Hope everybody had a good holiday. And holidays come up. We'll see everybody on Ask an Engineer in a few minutes.
Thank you,
See
everybody.
later. Bye-bye.